Let's take a look at solving quadratic and other polynomial equations using factoring. And typically people talk about quadratic equations, okay, but you can solve polynomial equations by factoring. Now, quadratic just means it's a polynomial, but it's specifically degree 2, meaning x is squared or the variable squared. But you can solve higher degree polynomial equations by factoring as well. Before we get into how to do it, let's explore this nice property of the number 0. Okay, um, let's say we have three numbers multiplied together, like a times b times c. A, b, and c are numbers. A, b, c means a times b times c. And if that equals 0, then what can we say about a, b, and c, right? So three numbers multiply to be 0. A times b times c equals 0. Then what can we say? Then we can say that one of those three numbers has to be 0, right? So a equals 0, or b equals 0, or c equals 0. Okay? Now, it's important to understand why this works. There's a couple reasons that it works. You have to have multiplication. You have to have things multiplied together to equal 0 for this property to work. For example, if a times b times c equals 16, that does not mean that a has to be 16, or b has to be 16, or c has to be 16. That is false, okay? You have to have 0 for this to work. And if you have addition or subtraction or division mixed in, it doesn't work either. So it has to all be multiplication, and you have to have 0 on one side, okay? So if you have things multiplied together, it can be three things like it is here. It can be four things. It can be two things. But regardless, if you have stuff multiplied together to be 0, one of those pieces has to be 0. One of those factors has to be 0. So let's look at another example of this. Let's say we have 2x times x minus 3 times 4x minus 1 equals 0. Then what can we conclude? Well, we once again have three things multiplied. We have 2x times x minus 3 times 4x minus 1, and it equals 0. So we can conclude that 2x equals 0, right? The first thing that's multiplied, or the second thing, x minus 3, equals 0, or the third thing, 4x minus 1, has to be 0. And what this allows us to do then is to take each of these and figure out what x equals, right? When we solve equations, we want to know what x equals, or what the variable equals, okay? So for example, in this case, we could say x equals 0, because if you divide both sides by 2, you can see that x equals 0. Over here, if you add 3 to both sides, you get x equals 3. And over here, you add 1 and then divide by 4, you get x equals 1/4. Okay, so you can start to see how this property of 0 helps us to solve equations. The key is that one side has to be factored, meaning all multiplication, and the other side has to be 0, and then we can conclude that one of those things has to be 0. Okay, let's work some problems where we actually factor now. So here's an equation, u squared equals 18u. And see how this is a higher degree than 1. That tells us we're going to have to use factoring and the 0 property that we learned, okay? We know that we have to do that because we have a higher degree than 1. So what we need to do is get 0 on one side. I'll do that by subtracting 18u from both sides, giving us 0 on the right side. And on the left side, we have u squared minus 18u. So now we have 0 on one side. Now we need to factor the other side, because the other side has to be all multiplication, and right now the left side is subtraction. Okay, so we have to factor it. Now we look at this, it's in descending order. We need to pull the GCF out, which is u. So we get u times u minus 18 equals 0. Now it's all factored equals 0. So I have two things multiplied together to be 0, which tells me that one of those two things, u, has to be 0, or the other thing, u minus 18, has to be 0. Now when we see the directions solve, what that means is that our last step should be u equals. Okay? We're trying to figure out what u equals. So we come down here and we can see, okay, u equals 0 is one answer. Over here, u minus 18 equals 0 tells us that if we add 18 to both sides, that u could be 18 also. So we get two answers here, u equals 0 or u equals 18. Those are the two values for u that make the original equation a true statement. And you could check that by plugging 0 in for both u's to see if it's true, and then plugging 18 in for both u's to see if it's true. All right, let's try another one, and I won't write so many details this time. Let's say we want to solve w squared plus w minus 12 equals 0. Now again, this is higher than degree 1, so that tells us we need to factor and use the property of 0, and we already have 0 on one side, so now all we have to do is factor the other side. So this is a trinomial. You could go through and factor it by grouping, and if you did, I'm not going to work in those steps, so let me put a dot 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 here. I'm assuming you know how to factor. You get w plus 4 times the quantity w minus 3 equals 0. And now the left side's factored and the right side's 0, so I've got this w plus 4 times w minus 3. Those two things multiply together to be 0. So that one of those two things, w plus 4 equals 0, or w minus 3 equals 0. And then we finish solving for w. So w equals negative 4, or w equals 3 if we get w by itself in each individual equation. And those are the two solutions to that equation. Now we have a much more difficult equation to solve. Now, the idea is still the same. What we notice is that we have a higher degree here, which means we're going to factor. We're going to have 0 on one side and factor the other side. But we also we have these parentheses. We have x's everywhere. So we need to get rid of the parentheses first so we can see what kind of equation we have. Sort of clean up the mess, okay? So on the left side, we have 2x squared minus 19x plus 53. And on the right side, if we go off to the side here, we're going to be careful on the right side. X minus 7 squared is the same thing as x minus 7 times x minus 7. And if we multiply all of this out, we get x squared minus 7x minus another 7x, which is minus 14x, plus 49. So x minus 7 quantity squared is this. So now we have no parentheses. We can easily move things around in this equation now, get 0 on one side. So I'm going to subtract x squared from both sides, which is going to give me 2x squared minus 1x squared is 1x squared. I will add 14x to both sides, giving me negative 5x on the left side. Negative 19 plus 14 is negative 5. Over here it's 0, by the way. And finally, I'll subtract 49 from both sides, which gives me positive 4 on the left. And on the right, everything cancels, leaving behind 0. So now I've got my 0 on one side. Now I need to factor the other side so that it's all multiplication. If you factor this trinomial by grouping again, you'll get x minus 1 times x minus 4 equals 0. So we have two things multiplied together to be 0, which means that x minus 1 has to be 0, or x minus 4 has to be 0. Finally, we can conclude that x has to be 1, or x has to be 4. And those are the two solutions to this polynomial or quadratic equation. Okay, this will be our last example. Again, it's a higher power than 1, which tells us we are going to factor. We're going to solve by factoring. And I need to get 0 on one side first. So I'll subtract 50x from both sides. Now I need to factor the left side. And I can see that it's in descending order, so the next thing I look for is a GCF, which is 2x. So I pull out my greatest common factor of 2x, leaving behind x squared minus 25. Now, this x squared minus 25 factors further. It's a difference of squares, and we can factor it using conjugates. So I carry down my 2x, and x squared minus 25 factors as x plus 5 times x minus 5. Now I have three things multiplied together to be 0. So one of those three things has to be 0. So 2x has to be 0, or x plus 5 has to be 0, or x minus 5 has to be 0. The first equation, if I divide both sides by 2, I get x equals 0. Here I subtract 5 to get x equals negative 5. Here I add 5 to get x equals positive 5. And there are the three solutions to this equation. Let's do one more similar example just so you can see it once. In this example, it's very similar to the last one except we're missing some x's, but you still get 0 on one side and try to factor the other side. Now that it's factored, we have a conclusion to make. We have three things multiplied together to be 0. So one of those three things has to be 0. So 2 has to be 0, or x plus 5 has to be 0, or x minus 5 has to be 0. Well, 2 can't be 0, right? 2 doesn't have a variable in it, it's just a number, and 2 and 0 are not equal. So this first one's not possible. So no matter what x is, this isn't possible, so we don't worry about that. But here we can see that x could be negative 5, and here we could see that x equals positive 5. So we only get two solutions in this particular equation. And if you plugged in either one of those values for x, excuse me, the equation would be a true statement. So anytime you have just a number here, that number can't be 0. So you basically can write it the way I did here, or you can ignore it. But over here, if that number has a variable multiplied by it, you can see that you can, in fact, solve for the variable. Okay, so that's how to solve polynomial equations or quadratic equations by factoring.